So for our final example of selection bias, I want to mix it up and give you something a little bit different. This is called full adherence, and we're going to be dealing with this type of problem a lot in the future. So let me go ahead and introduce you to a new type of variable. So this new type of variable will be a treatment variable, z. And z will be whether we treated someone with a specific treatment. So for example, it might be giving someone pills to take for a year. So 1 pill a day for an entire year. Now, we know it's very hard to do something for an entire year, take medication on time for an entire year. Lots of people don't do this. And so we have a different variable, a, as to whether they actually did treat themselves for a full year with these pills. So let's say these are pills for Alzheimer's or dementia. And let's say we have some sort of other effect, which might be the susceptibility to dementia in the first place. Susceptibility for dementia might affect how likely you are to take these pills, and it might also affect the outcome we are interested in, whether patients do end up with dementia or not, or what age they end up with dementia or not. Okay, so question. This is kind of a very interesting question. Is Z associated with Y? Okay, well let's just go ahead and write this down. So we have necessarily Z. This affects A. So right, this is the true treatment value, which is affected by a U, which is an unmeasured effect, which is sort of your susceptibility for dementia, which again in turn affects Y. So we're going along here, looking at the path, and then boom, blocker at A. So in fact, Z is not confounded based on this diagram. That being said, how interested are we in Z? This is kind of an interesting idea. Z is not necessarily the effect of the treatment on dementia. So Z is more the effect of allowing people to do the treatment. So what we call this, generally speaking, is intention to treat. Intention to treat. So ITT. So we'll call this an intention to treat effect, because the effect of intending to treat the patient, so giving them the medication, we can measure here. There's no confounding, at least in this specific diagram itself. However, we cannot measure the actual effect of A, the effect of treatment. In fact, even if we were able to measure A in this case is confounded by some unmeasured variable U. So in this case, we couldn't actually find the true causal effect between A and Y. So one last thing, this is a little bit of a technical note. So first off, sometimes we are interested in the intention to treat effect, sometimes it's the best we can do. But on sort of a second note here, the intention to treat effect, if we assume monotone effects, this is a bit technical, if we assume monotone effects in the population, so that people that are treated more necessarily receive more or less, so if the treatment is positive, they'll receive more benefits, and if the treatment is negative, they'll receive less benefits. So if we assume the monotone effects, these intention to treat effects are attenuated versions of the true effect of the population. So what does that mean? So that means, generally speaking, intention to treat effects under assumption of monotonicity of treatment, of individual treatment effects, are smaller than what the actual treatment effects might be. And so that might be good. So if you're measuring, like, for example, a drug on cholesterol, and you do see a and you use attention to treat effect, and you do see a causal link between the reduction of cholesterol and under the intention to treat effect, you can know that the true effect, right, the true effect of actually forcing everyone to take that medication will be more. So it's actually even better. You'll even get an even bigger boost to the reduction of cholesterol. So attention to treat effects can sometimes be measured. You'll see them in a lot of statistical papers out there. And they also have a close connection to instrumental variable analysis, which we'll be talking about in a bit.